Example 2. A bicycle moves along a straight road such that its position is described by the graph shown below. Construct the BT and AT graphs for the interval 0 to 30 seconds. So we have the position graph, and again we have our relationship position, velocity, acceleration. So if I want to move from this side to this side, I'm going to derivate in terms of the time. If I'm moving from this side, I have to integrate in terms of time. So let's see what we have. We have the position, and they're asking us for velocity and acceleration. So we have to derivate twice. And then we have two functions. We have a function for the time interval 0 to 10 seconds, where the position is equal to st to a second, and then we have another function for the time interval between 10 and 30 seconds with a function of 20t minus 100. So let's start with the VT graph. Right, so we know that the velocity in this case is the change in position over the time. So I just have to derivate my position function to find the velocity function. We have two intervals. We have an interval between 0 and 10 seconds. The function here is equal to st squared. So my velocity is just the derivative of that, which in this case will be 2t. Velocity feet per second. And then between 10 and 30 seconds, we know that this is s equal to 20t minus 100. The velocity is the derivative of that function, which in this case will be 20 feet per second. This is position, so the units here will be feet and feet. So if we graph this, we have 10, 20, 30. So from 0 to 10, the velocity is 2t, so it's a linear relationship. So when this is 0, is 0. When the time is 10, 10 times 2 is 20. So let's do 10, 20. This is 20. And then between 10 and 30 seconds, it stays at 20. Okay, so this is v equals to 20. And then this is v equals to 2t. This is velocity in feet per second. And then this is time in seconds. Step 2 would be the AT graph. We know that the acceleration is the change in velocity. So we can do something similar. So now we have between 0 and 10 seconds. The velocity we found is 2t feet per second. Then the acceleration will be the derivative of that, which in this case will be 2 feet per second square. And between 10 and 30 seconds, we found that the velocity is 20. And the acceleration will be the derivative of that. And the derivative of a constant is equal to 0. So now we can graph this. T in seconds. Acceleration is feet per second square. Then we have 10, 20, 30 seconds. Between 0 and 10, the acceleration is 2. I'm gonna say this is 2. And then between 10 and 30 is 0. So this just drops and stays at 0.